We are going to start now the next chapter, chapter 8 of class 10th mathematics. It is Introduction to Trigonometry. So, trigonometry is the branch of mathematics which deals with the measurement of angles and their allied problems related to these angles. So, the first thing that we have to study is the trigonometric ratios. These are also called the T ratios. So, T ratios are corresponding to a right angled triangle. We are talking about there is a right angled triangle. One of its angles will be acute angle. If it is right angle, then automatically the other two angles will be the acute angles. So we are going to define the trigonometric ratios or the T ratios corresponding to this triangle. So first of all, we define some terms related to this triangle. So we are saying the triangle ABC is given to us. This AB, this is called the base. This angle at B, it is 90 degrees. The side opposite to this 90-degree angle, this is called the hypotenuse, and this angle, this angle 90 degree, it is formed between base and the perpendicular. These are the fixed terms we are talking about. This is the base, this is perpendicular. The side opposite to this 90-degree angle, it is called the hypotenuse. And we are talking about the angle theta, that is the angle between base and the hypotenuse. This is the angle theta we are talking about. That base and hypotenuse, they make an angle of theta, and this angle we are saying it is an acute angle. Acute angle means the value of this angle is less than 90 degrees. Now the measure of all these sides, these are given to us, that the base length it is x, the height of this perpendicular it is y, and the length of this hypotenuse it is r. So based upon all these terms, we are going to define the T ratios, that is called trigonometric ratios. So the first trigonometric ratio for theta we are saying this angle is theta. We are talking about the trigonometric ratios corresponding to this angle theta. We are saying if this angle is theta, it means this AB is the base, this BC is the perpendicular, and this AC is the hypotenuse. So there are certain terms that are defined over here. The first term that is defined is sine theta. So sine theta is perpendicular over hypotenuse. You have to remember this value. So we are talking about the perpendicular, the length of perpendicular over here it is y, and hypotenuse it is r. So we are saying the formula for sine theta it is y by r. And sine theta we also write it like sin of theta. This is the short form we will use throughout this chapter. Next is cosine theta. So cosine theta is, the formula for cosine theta is, it is base over hypotenuse. So it is base over hypotenuse. This is called cosine theta, and the formula for this becomes x over r, and cosine theta in short form it is written as cos theta. Third we have is tangent theta. These are the definition, these are the terms that you have to remember. First is sine theta, second is cos theta, third is tangent theta. And tangent theta is perpendicular over base. So value of perpendicular we have it is this y, and base we have it is x. So the formula for the tangent theta we have it is y over x, and it is also written as tan theta. This tangent theta in short form we can write it is tan theta. These all notations, these all definitions, these are standard definitions. You cannot change anything in these definitions. It is not that you can change according to your wish. These definitions, these are fixed, that how tangent is defined, it is perpendicular over base. So in this figure we are saying it is y over x. And what is this? We are talking about tangent theta. Theta is this angle. corresponding to this angle, this is the base and this is the hypotenuse, and that is why we are saying the value is y over x. The next angle we have is cotangent theta. So it is also mentioned over here that this the next is cosecant theta. It is not cotangent, it is cosecant theta, and cosecant theta, it is mentioned over here, this is just the reciprocal of sin theta. So what is the value of sin theta we have? We are saying sin theta is equal to perpendicular over hypotenuse. So cosecant theta, that will be equal to 1 over y over r. So that is equal to r over y. Next we are talking about is secant theta. So cosecant theta, it is written as cosec. Next term we have is secant theta. So secant theta, it is mentioned over here, it is the reciprocal of cos theta. So this becomes 1 over r over x. So that is equal to x over r. That is, it is equal to hypotenuse over base. This value we are saying it is hypotenuse over base. So secant theta, we are saying it is reciprocal of cos theta. And the last we have this secant theta, it is written in this form, short form, it is sec theta. And the last one we have, it is cotangent theta. Cotangent theta is also written as cot theta, and cot theta is just the reciprocal of tangent theta. So the formula for this, it is 1 over tangent theta, we know it is perpendicular over base, so it is x over y, and we are saying the definition for this, it is base over perpendicular. So this is the definition of cotangent theta, and or we can call it as cot theta. So these are the definitions related to the trigonometric ratios that you have to remember, you have to learn, that these are the definitions we have. Now next thing we are talking about is that T ratios of an angle are well defined. So what we are going to prove now is, we have to show that the value of each trigonometric ratio of an angle. Trigonometric ratio of an angle means that a right angled triangle is given and an angle is given over there. Corresponding to that angle, we will fix the base, perpendicular, and the hypotenuse. This is the angle between the base and the hypotenuse. And we are saying that the value, it does not depend upon the size of the triangle, but it only depends upon the size of this angle. What we mean to say is, suppose I am talking about a right angled triangle. I am not talking about the proof over here, I am just explaining what is the meaning of this term. This is the right angled triangle I am talking about. Suppose this angle we have, say it is 30 degree. We will have some length over here. Suppose this is x1, this is y1, and this value, it is z1. Now we are saying, if we will increase the length without changing this angle 30 degree, what we have done, the new base we have, it is x2, this length we have, it is z2, the height has increased to y2, but this angle is again 30 degree, then we are saying that the trigonometric ratios will not change. But if in the same triangle, we will change this angle, suppose the angle I have changed over here, this angle I have changed over here, say this angle I am talking about, say it is 20 degree, then the trigonometric ratios will change. So we are saying that the trigonometric ratios we are talking about, they does not depend upon the size of the triangle, but they depend only upon the angle we are talking about. So to prove this, we have considered a triangle ABC. This triangle ABC we are talking about. in which angle B is 90 degree. This angle at B it is 90 degree, and angle at A we are saying this angle over here it is theta. We have taken a point P on AC, this point we are talking about, and we have drawn this perpendicular PQ on AB. This is the perpendicular we have drawn. Then we are saying in triangle AQP, this triangle we are talking about, and triangle ABC, both these triangles, these will be similar to each other because this is the angle theta that is common over here. Both these angles, these are of 90 degree measure. So what we get is that AQ over AB, that is equal to AP over AC, that is equal to PQ over CB. This is from the similarity condition we are talking about. We get these values, these are equal to each other. So this gives us that PQ over AQ. We are talking about these two values, AQAB, PQBC. We have cross multiplied these terms over here. So what we get is that PQ over AQ, that is equal to CB over AC, and we know by the definition, we are saying we have a triangle over here, this angle is theta. We are talking about APQ triangle say. So we are saying this is PQ. It means we are talking about this is perpendicular. Then we have this is AQ. AQ means we are talking about it is base, so it is perpendicular over base. Similarly for the second triangle it is perpendicular over base. So and by the definition we know that this is equal to sine of theta. So what we get from this is, it is mentioned over here that APQ over AP, that is equal to CB over AC, that is equal to sine of theta. Similarly, we can prove that AQ over AP is equal to AB over AC is equal to cos theta. PQ over AQ equal to CB over AB is equal to tan theta. So in this case what we have done, we have decreased this side over here. For this triangle we have kept this angle as constant. So in the first case we are saying we have decreased this length, these two lengths we have decreased. Now in the next case we are saying if we increase these lengths, the new points we have, they are R and S. The new points we are getting, they are R and S. And as we have proved in this case, we are saying both the triangles ABC, that will be similar to the triangle ASR. These two triangles will be similar. And with the similar reasoning or same kind of calculations, what we will get is that the value of sine theta, cos theta and tan theta for these three angles, they will be same. So what we get is that if we keep the angle constant and we increase or decrease the sides of the triangle, then the trigonometric ratios, they will not change. So what we see from this is that the trigonometric ratio of an angle, they do not depend upon the size of the triangle. But if we are talking about, suppose we have a triangle over here, this is the right triangle we are talking about. If we change this angle, we are saying we have changed the value of this angle over here. This is the triangle ABC, this is the original triangle we have. Suppose that this angle of this original triangle, it is theta, and this new angle we are talking about is theta 1, this is theta 2. So what will happen over here is, this is the base B, same for both these. Earlier the height we are saying, say we are writing it with y1, the new height we will have it is y2. So if I am writing the value of sine theta 1, then the value is y1 over b. And if I am writing the value, this is not equal to y2 over b. So it is, and y2 over b, that is equal to sine of theta 2. So what we see is that if we change the angle of the triangle, then the trigonometric ratios, they will change. But if we will increase or decrease the size of the triangle, then the trigonometric ratios, they will remain same. Now next we have is consider a triangle ABC. We are talking about this triangle ABC is there, in which angle at B is 90 degrees. We are talking about a triangle. This is ABC. This angle at B, it is 90 degree, and angle at A, it is theta. So we are saying the longer side we have, it is the hypotenuse. We are saying this is the angle 90 degrees. So side opposite to it, it is the hypotenuse. This is the angle theta. It means this is the base for this triangle, and this is the perpendicular. I am repeating this thing again and again so that you should keep this thing in mind, that if angle theta is there, then these two are hypotenuse and base, and the angle opposite to theta, that is the perpendicular. Angle opposite to the side opposite to 90 degree angle, it is hypotenuse, and the side opposite to this angle theta, it is called the perpendicular. So we are saying that this hypotenuse, it is the longest side of the triangle. This thing we already know. So if we write the value sine theta, we are saying it is the formula for this, it is BC over AC, and we are saying that AC is greater than BC because AC is the hypotenuse of this triangle. So what we get is that sine of theta is always less than 1. Similarly, we are saying that cos of theta is always less than 1. So what we have is that sine theta, the value of sine theta and cos theta, they cannot be greater than 1. That is, these ratios we are talking about, they cannot be greater than 1. Next is the power of t ratios. This is just the notation again. So we are saying if we are writing sine theta square, sine theta square means I am talking about the formula we have, sine theta is equal to, if the triangle we are considering, it is in the form, it has side xy and r as we have discussed earlier, then the value we have, it is y over r. When we are squaring both sides, this is equal to y square over r square. This term I am talking about, sine theta square, this is also written as sine square theta. Both these notations, these are same. So we are saying that sine theta square we can write in the form sine square theta. This thing doesn't mean that it is n square or it is sine square only. In general, when we are writing something, we write it in this form in place of this. Similarly, if I am talking about sine cube theta, we can write it in this form, cos theta whole cube, that is equal to cos cube theta. So these notations, these are equivalent notations. You can use any of these. Next is, we have to prove that tan theta, that is equal to sine theta over cos theta. Now what is the definition of tan theta? Definition of tan theta is perpendicular over base, that is equal to y over x. If we divide the numerator and the denominator by r, what this term will become? Y over r, and this is the definition for sine theta, and this is the definition for cos theta. So what answer we get is that tan theta is equal to sine theta over cos theta. Next we are saying cot theta is opposite of or the reciprocal of tan theta. So its value is cos theta over sine theta. And third thing we have to prove is that the product of these two is 1. So we are saying that tan theta into cot theta, that is equal to tan theta into cot theta is 1 upon tan theta. These two gets cancelled and the answer we are left with is 1. So we are saying that tan theta into cot theta is equal to 1. Next we have is for any acute angle theta, we have to prove these three. So these are the identities we are talking about. These are the trigonometric identities. So the first thing we are going to prove now, it is sine square theta plus cos square theta is equal to 1. So how we are going to prove this is, suppose a right angled triangle, this ABC it is given to us. This angle at A it is theta degrees. So what we have is that if we write the statement of the Pythagoras theorem, or by the Pythagoras theorem we are saying we have x square plus y square equal to r square. We have this condition. Now if we divide this whole equation with r square, both sides we are saying we divide it with r square, what we get is that x square over r square plus y square over r square is equal to 1. So it is x over r square plus y over r square, that is equal to 1. Now what is x over r? It is sine of theta square plus cos of theta square, that is equal to 1. And this thing we can also write it as sine square theta plus cos square theta, that is equal to 1. And this is our first identity we are talking about, that sine square theta plus cos square theta, that is equal to 1. Now we are starting from this identity. Now suppose I divide this whole identity with cos theta. What we are saying, it is sine square theta plus cos square theta over cos square theta is equal to 1 over cos square theta. We separate these terms, we get it is sine theta over cos theta square plus cos square theta plus cos square theta over cos square theta, that will become 1. We are separating the denominator over here. Once we have separated these two terms, then we have separated these two terms, and the answer we are getting, it is 1 over cos square theta. What is sine theta over cos theta? We already know it is tan theta. So it is tan square theta plus 1. And what is 1 over cos square theta? It is secant square theta. And this is our second identity. Now the third identity we have, it is 1 plus cot square theta is equal to cosecant square theta. So in this case we have divided it with cos square theta. So in place of this, if we divide this term sine square theta plus cos square theta equal to 1, we have this equation, and we divide this with sine square theta on both sides. We are dividing this with sine square theta on both sides. So on separating these terms, we will get it is 1 plus cos square theta over sine square theta, that is equal to 1 over sine square theta. Cos square theta over sine square theta, we know it is cot square theta, and 1 over sine square theta, that is cosecant square theta. So we obtain this third identity over here, that 1 plus cot square theta, that is equal to cosecant square theta. So these are the three trigonometric identities we have. This is how you can remember these identities. If you forget, you can just derive these identities. Another way to prove these identities is that we have started with the left hand side of first equation. We are talking about sine square theta plus cos square theta. We have started with this term. We have written the value of sine square theta, it is y over r whole square. Cos square theta, it is x over r whole square. We have taken the LCM over here. The numerator part we will get it is x square plus y square. And by Pythagoras theorem, we know that x square plus y square is equal to r square. So the final answer we are getting it is 1. To prove the second part, we are saying this thing we have done, we have derived these identities. We are not proving these identities. It is also a kind of proof, but we are saying we have started with the Pythagoras theorem and we have derived all these three identities. Now we are talking about, we are proving these three identities. So we are starting from the left hand side of one identity, and we are showing that we have reached the right hand side of that identity, and we say that this identity holds. So we are, what we have done, in place of tan theta we have written it is y over x whole square. When we take the LCM, in the numerator part we get x square plus y square, that value is r square. It becomes r by x whole square, and this value is secant square theta. So similarly we can prove the third one. So we are saying we have three identities. First is sin square theta plus cos square theta is equal to 1. Second is 1 plus tan square theta is equal to secant square theta. And third identity we have is 1 plus a cot square theta is equal to cosecant square theta. So these identity you must learn, you must remember these three identities. Now next are some questions based upon these identities. So first is, if sine A is equal to 8 by 17, we have to find the other trigonometric ratios of angle A. So we are saying, suppose the triangle we have, this is ABC, this is the triangle. So what we get is that sine A is equal to 8 by 17. This is given to us. So what we can do is that sine A is this angle over here. It means this is the base, this is the hypotenuse, because angle opposite to B we are saying it is 90 degree. This is the perpendicular. We know that sine theta is equal to perpendicular over hypotenuse, and its value is given to be 8 by 17. So for some constant k, we are saying BC is equal to 8k and AC is equal to 17k. Whatever the length of these sides are, we are saying some k is there, for which BC is equal to 8k and AC is equal to 17k. Now what we have to do is, we have to find the value of this. We have calculated this value, it is 8k. We have calculated this value, it is 17k. We have to calculate the value of the third side. So the value of the third side will be square root of 17k square minus 8k square. Now k will come out of this bracket, and what we are left with is, it is 289, that is 17 square minus 64. So it is k into square root of 225, and this value comes out to be 15k. So we are saying the base over here we have, it is 15k. Now we have just to apply the formula. So the first angle that is already given to us, it is sine A, that is equal to perpendicular over base. Perpendicular is 8k, perpendicular over hypotenuse. Perpendicular is 8k and hypotenuse is 17k. Next we are talking about is cos A. Cos A is base over base is 15k and the hypotenuse it is 17k. So the answer we get, it is 15 by 7. Next is tan. Tan is sine A over cos A, or you can directly write the value as tan is perpendicular over base. So it is 8 by 15 is the answer. Now cosecant A, we are saying it is reciprocal of sine A. The cosecant A we have, it is reciprocal of sine A. The value of sine A we have 8 by 17. So the value of cosecant A we have, it is 17 by 8. Similarly, this secant A is inverse of or reciprocal of 1 cos A. So the answer we get for cos A, it is 15 by 7. So this answer is 7 by 15. Similarly, cot A is reciprocal of tan A. So the answer we get for tan A, it is 8 by 15, and for cot A it is 15 by 8. Next we have is, if cos A, that is equal to 9 by 41. We are saying the value of cos A is 9 by 41, and we know that for the triangle ABC, we have shown over here, this is the triangle ABC. Cos A means we are talking about, it is base over hypotenuse. So base we have it is AB and hypotenuse we have it is AC. The angle A we are saying this is angle A. The sides, this is 90-degree angle. So this is hypotenuse. This is angle A over here. It means this is the base and this side it is the perpendicular. So for some constant K, what we get is that AB is equal to 9K, AC is equal to 41K. So this value is 9K and this value is 41K. So value of perpendicular we will have, it is square root of 41K square minus 9K square. So this is equal to, K will come out of the square root and the values we will get, it is square root of 41 square minus 9 square, and this is equal to K into square root of 1681 minus 81, that is equal to K into square root of 1600, and this comes out to be 40K. So we are saying the length of this perpendicular, it is 40K, hypotenuse is 41K, and base we have it is 9K. So the trigonometric ratios we will have, it is sin A, that is equal to perpendicular over hypotenuse. Perpendicular is 40K over hypotenuse is 41K. So answer we get, it is 40 over 41. Cos A, it is already given to us. Then we are talking about it is tan A, that is equal to perpendicular over base. So perpendicular is 40K and the base we have it is 9K. So the answer for tan we get, it is 40 over 9. For tan A, the angle we are getting, it is 40 over 9. Next we are talking about it is cosecant of A, and we know that cosecant of A, that is equal to 1 over sin A. So that will be equal to 41 over 40. When we are talking about the secant A, it is 1 over cos A. So answer we will get, it is 41 over 9. And last we have it is cot of A, that will be 9 by 40, because cot A is 1 over tan A. Now the next we have is, if tan A is equal to root 3. So tan of A, when we are talking about, we are saying this is the triangle ABC. This angle is A. It means this is the base. Then this opposite to this is the hypotenuse, and this is the perpendicular. So when we are talking about tan is equal to root 3, so what we are saying is this is equal to BC over AB. It is perpendicular over base. So we get BC is equal to root 3K for some K. AB is equal to 1K, because this root 3 we can write it is root 3 over 1. So we are saying this value comes out to be 1K and this value comes out to be root 3K. So these are the sides that we obtain, that this AB side, this is K, and this BC side, it is square root of 3K. So when we calculate this side AC, it will be square root of root 3K square plus K square. K comes out of the bracket and it is 3 plus 1. So answer we are left with is 2K. So we are saying that this length AC, it is 2K. So the value of sin A, that is perpendicular over hypotenuse. Perpendicular is root 3K, hypotenuse is 2K. So the answer we get, it is root 3 by 2K. Suppose we have directly to write, we are talking about the value, what is secant of A? It is 1 over cos of A. What is cos A? Cos A means we are talking about the value we have calculated, it is 1 by 2. So it is 1 over 1 by 2, that is equal to 2. In place of this, you can directly write that secant A, that is equal to hypotenuse over base. This is by the definition of the secant. So hypotenuse we have it is 2k and the base we have it is k. So answer we are getting it is 2 over here. Both the answer these are same. So you can use any of these method. You can directly use the definition that secant is hypotenuse over base, or you can use that secant is 1 over cos. Similarly for the tan a, you can, we are talking about tan of a, you can write it like sine a over cos a. Sine a we have calculated 3 by 2 over cos a it is 1 by 2. So answer is root 3 by 2 into 2, that is equal to square root 3. I am talking from these values. Or you can directly write it as perpendicular over base. Perpendicular is root 3k and base it is k, so answer it is root 3. In this question the value of tan is already given to you. I am just talking about if suppose you have to calculate tan a, you can use any of these methods. If you have to calculate cot a, you can use it as 1 over tan a, or you can use it as cos a over sin a, or you can use it as base over perpendicular. So in all these three cases the answer we will get it is 1 by root 3. So it is up to you that how you want to find the trigonometric ratios. Now in this next question we have given that secant theta is equal to 25 by 7. We have to find all other trigonometric ratios. So we have drawn the triangle over here. This is the triangle ABC. We are saying the angle at A is theta. So it means this AB is the base. This angle B is 90 degree. This is the hypotenuse. And this BC is the perpendicular. Now the formula for secant theta we know it is hypotenuse over base. Why? Because it is opposite of 1 over cos theta, and cos theta we know it is base over hypotenuse. So opposite of this will become hypotenuse over base, and this value comes out to be, hypotenuse we have it is AC and base we have it is AB, and this value is given to be 25 by 7. So what we get is, for some constant k, AC is 25k, AB is 7k. So this value we are saying it is 7k, this value we are saying it is 25k. So we can calculate the value of BC as square root of 25k square minus 7k square. K will come out of the square root, and what we are left with is 625 minus 49, that is k into square root of 576, and this is 24k. So we are saying that the value of BC it is 24k. So we have the value of base, perpendicular and hypotenuse. So the value of sine, the formula for sine theta we know it is perpendicular over hypotenuse. So answer is 24 by 25. The formula for cos theta we know it is base over hypotenuse. So answer we get it is 7 over 25. Next we are saying the value of tan theta we will have it is perpendicular over base, so it is 24 over 7. 24 over 7. Value of cosecant theta we will have it is 1 over sine theta, so that is 25 by 24. The value of secant theta, that is already given to be 25 by 7. It is converse of or reciprocal of 7 by 25. And last we are talking about it is cot theta, that is the reciprocal of tan theta. So answer we get it is 7 by 24. So these are the trigonometric ratios corresponding to secant theta is equal to 25 by 7. So it means if one of the trigonometric ratios it is given to us, then we can calculate all other trigonometric ratios. Now next is, if cos theta is equal to 3 by 5, we have to find the value of this term, that is 5 cosecant theta minus 4 tan theta over secant theta plus cot theta. We have to calculate this value. It means we have to calculate the values of all these trigonometric ratios. Now cos theta is 3 by 5. We have drawn the triangle over here. This is the triangle ABC we are talking about. In this angle we are saying this is angle A, it is theta. So it means the value of cos theta means it is given that AB over AC, that is base over hypotenuse, that is 3 by 5. So we get AB is equal to 3k for some k and AC is equal to 5k for some k. These values we are talking about, this is 5k and 3k. So the value of BC we have that will be equal to 5k square minus 3k square. K comes out to be common. It is 25 minus 9, that is equal to 4k we are talking about. So we are saying the value of this BC, it is 4k. Now what values we require? It is 5 into, we are talking about this term over here, it is 5 into cosecant theta, and the formula for cosecant theta we know it is hypotenuse. The value of hypotenuse we are saying it is 5k over the perpendicular, it is 4k, minus 4 times it is tan theta, so it is 4k over 3k, divided by secant theta. Secant theta is the reciprocal of cos theta, so it is 5k over 3k, plus cot theta, it is base over perpendicular. These all k, these gets cancelled. So what we are left with is 25 over 4 minus 16 over 3 upon 5 over 3 plus 3 over 4. And on taking the LCM, this is 12, this is 75 minus 64 over 20 plus 9 over 12. The answer we will get, it is 11 by 12 into 12 by 29. Why this is 12 by 29? This is over here. When it gets multiplied, the terms there, the numerator becomes the denominator and denominator will become the numerator. So the answer we will get, these two 12, this gets cancelled, and answer we are left with 11 by 29. So we are saying the value of this term, it is 11 by 29. Next is, if secant theta is equal to 5 by 4, we have to show that 2 cos theta minus sin theta over cot theta minus tan theta, that is equal to 12 by 7. So again we are saying secant theta, we know it is hypotenuse over base. So in this triangle that is given to us, we are saying it is AC over AB, and this value is given to be 5k over 4k. So the value of AC, we are saying this value is basically given to be 5 by 4. So we are saying AC is 5k and AB is 4k. So these values we are talking about, AB it is 4k, AC it is 5k. So value of AC, this is 5k square minus 4k square, and the answer we get, that is equal to 3k. So the values now we want to calculate, it is 2 into cos theta minus sin theta over cot theta minus tan theta. So what is the value of cos theta we have? It is base over hypotenuse. So it is 4 over 5. We are saying it is k over here, and both these k, these gets cancelled. Then it is minus sin theta. Sin theta is 3 over 5. K already gets cancelled. Then the next value we are talking about, it is cot theta. Cot theta is 4 over 3. We are saying these values, they will have k with them. These k's will get cancelled. These k will get cancelled. And the last value we will have, it is tan theta. And the value of tan theta we will have, it is 3 by 4. On solving this, we are saying we have to multiply these two terms. We get it is 8 by 5 minus 3 by 5 over 4 by 3 minus 3 by 4. So this gives us 5 by 5 over 7 by 12. that is equal to 1 into 12 by 7. So the answer we are writing it is 12 by 7. So we are saying that the value of this term comes out to be 12 by 7. Next is in a triangle ABC, it is given that angle B is 90 degree and ratio of AB is to AC, it is 1 by is to root 2. So we are saying a triangle ABC we have drawn over here. This is the triangle ABC and it is right angled at this B. The ratio of this AB is to AC. This is given to be 1 is to root 2. So we have to find the value of this. So it means we are talking about this angle is A. It means we are saying this is the base and this is the hypotenuse. This angle is 90. It means this is the hypotenuse. So what we are given is AB over AC. That is equal to 1 by root 2. It means this is the value of cos A that is given to us. Now, so we are saying that the values now we have it is AB is equal to K and AC is equal to root 2K for some constant K. So we are saying this value AB, we are saying this length is K and this AC length it is root 2K. So the length of this BC that will be root 2K square minus K square and this comes out to be 2K square minus K square and that is equal to K. So we are saying the length of this term it is K. Now the value we want to calculate it is 2 tan theta, that is 2 tan theta over 1 plus tan square theta. We want to calculate this value. So what is tan A over here? It's not theta, it is A over here. So tan A means we are talking about it is K over K. The value of tan A we have it is K over K, that is equal to 1. So we are saying this value is 1 and this value is 1 and on solving this we get it is 2 over 2, that is equal to 1. So the value of this term, the required term, it is 1. Now the next is if 3 tan theta is equal to 4, we have to evaluate the value of this term. So there are two methods to solve this. First is that from this equation we are saying tan theta is equal to 4 by 3. This is the value of perpendicular over base. It means if we draw the triangle, the right angle triangle, this is the value 4K, this is the value 3K. When you will solve this, you will get this is the value 5K. From using this triangle, you will calculate the value of sin theta, cos theta and put in this equation. Second thing what we can do is, we can write it is sin theta plus 2 cos theta over 3 sin theta minus 2 cos theta. What we are going to do is, we are going to divide the numerator and the denominator with cos theta. When we separate this denominator, we get it is 3 times tan theta plus 2 over 3 times tan theta minus 2. We are separating these terms. This will become 3 tan theta sin theta over cos theta. When we separate these terms, cos theta and cos theta will get cancelled and this whole term will become 2. Now we have the value of tan theta is 4 by 3. So the answer we will write it is 3 into 4 by 3 plus 2 over 3 into 4 by 3 minus 2. This 3 gets cancelled. So what we are left with is 6 by 2, that is equal to 3. Similarly, in this next question, the value of 5 cot theta is equal to 3 is given. It means cot theta is equal to 3 by 5. Now if we divide in this term, what we have is 5 sin theta minus 3 cos theta over 4 sin theta plus 3 cos theta. The value we have it is for the cot theta. So what we are going to do, we are going to divide the numerator and the denominator of these terms with sine theta. What we have done over here, we have divided this whole numerator, or we have multiplied it with 1 by sine theta. We have multiplied it with 1 by sine theta. When this sine theta goes inside, it is divided, or we are saying 1 by sine theta is multiplied with both these terms. This sine theta cancel. Cos theta over sine theta will become cot theta. Cos theta over sine theta will become cot theta. The value of cot theta we have it is 3 by 5. So the final answer we will get it is 5 minus 3 into 3 by 5 over 4 plus 3 into 3 by 5, and on solving this the answer we will get it is 16 by 29. Now the next question we have is that if 7 sine square theta plus 3 cos square theta that is equal to 4, we have to show that tan theta is equal to 1 by square root 3. Now the identity we know is that sine square theta plus cos square theta that is equal to 1. So this gives us cos square theta is equal to 1 minus sine square theta. So in place of cos square theta, if we write 1 minus sine square theta, we get 7 sine square theta plus 3 into 1 minus sine square theta. This is equal to 4. So it is, when we open these brackets, we are left with this 4 sine square theta plus 3 is equal to 4. So it is 4 sine square theta equal to 1. So this means sine square theta is equal to 1 by 4. If we substitute this value of sine square theta in this equation, we will get cos square theta is equal to 1 minus 1 by 4, that is equal to 3 by 4. So the value of tan square theta that we will have, it is sine square theta over cos square theta, and that is 1 by 4 into 4 by 3. This is the value of sine square theta, and this is the value of 1 over cos square theta. This gets cancelled and we are left with 1 by 3. So the value of tan theta that we will get, it is 1 by square root of 3. We are saying when we are solving this term, tan square theta is equal to 1 by 3, we will get two answers, that tan theta is equal to 1 by 3 and tan theta is equal to minus 1 by 3 when we are doing the square root over here. But we are not interested in these kind of answers, because the trigonometric ratios, the definition we are talking about for the trigonometric ratios, we are saying that their values should be positive. These are corresponding to the sides of the triangle. So we are saying that this negative value is not possible. So the answer we are left with is that tan theta is equal to 1 by square root 3. Next is cot theta. This value, it is given to be 15 by 8. We have to calculate the value of this term. It is 2 plus 2 sine theta into 1 minus sine theta over 1 plus cos theta into 2 minus 2 cos theta. So we can write this term, if we take 2 common, it is 1 plus sine theta into 1 minus sine theta over 1 plus cos theta. We have taken 2 common, and what we are left with is 1 minus cos theta. Now this numerator part we are talking about, this is 2 into 1 minus sine square theta, and this denominator part we have this 2 and 2, where we can cancel these two, we need not 2 over here, and this denominator part, it is 1 minus cos square theta. The relation we already know, we have mentioned over here, that sine square theta plus cos square theta is equal to 1. From this we can get cos square theta is equal to 1 minus sine square theta. And from this same relation, we can also write that sine square theta is equal to 1 minus cos square theta. So we have two relations over here. and these are the two values we are talking about. This is 1 minus cos square theta and this is 1 minus sin square theta. So we are saying this value becomes cos square theta over sin square theta, that is equal to cot square theta. The value of cot theta is 15 by 8 given to us. So the answer we get it is 15 by 8 whole square, that is 225 by 64. So this is our answer. Next is in a triangle ABC, right angled at B. This triangle, it is right angled at B. It is given that AB is 5 centimeter, BC is 12 centimeter. If it is right angle triangle, it means the value of this length, it is square root of 12 square plus 5 square, that is square root of 144 plus 25, that is equal to square root of 169, and that is 13 centimeter. So we are saying the length of this AC is 13 centimeter. We have to find the value of sine A. So sine A, we know it is perpendicular over hypotenuse. We have to calculate the value of secant A. Secant A, we know it is hypotenuse over base. We have to calculate the value of sine C. What is different in this question, that these two values, these are sine C, these two values, these are sine A. So what we are saying is, when we are talking about the angle sine A, we are talking about the trigonometric ratio corresponding to A. This is the angle A we are talking about. This angle is 90 degree. What we are saying is, the side opposite to this 90 degree angle, this is the hypotenuse. We are talking about the trigonometric ratio corresponding to this A, it means this is the base and this is the perpendicular. Now our question is changed and we are talking about this is triangle ABC is there. We are talking about this angle C is there and we are talking about the trigonometric ratios corresponding to this. This angle at B is 90 degree. It means this side is hypotenuse. We are talking about the trigonometric ratios corresponding to this angle C. So it means this side we are talking about, this BC side, this is the base and this AB is the perpendicular. Then we are talking about the trigonometric ratios of angle C. Now we have the values over here. This is 12, this is 5 centimeter, 12 centimeter, and this is 13 centimeter. Now what we have to calculate? We have to calculate sine C. The value of sine, we know it is perpendicular over hypotenuse. Now what is perpendicular over here? When we are talking about this triangle, the perpendicular is this AB. So we are saying the perpendicular now it is AB and hypotenuse it is AC. So answer we will get, it is 5 over 13. This answer is mentioned over here. That is the corresponding to the angle C. Sine C is 5 over 30. Similarly, secant C will be AC over BC. Why? The formula we have, it is for secant C, it is hypotenuse over base. Now what is hypotenuse over here? It is 13 centimeter, that is AC. Now the base corresponding to this, we are talking about the base for this triangle, it is BC. We are talking about this value base, it is BC, and the answer we are getting, it is 13 by 12. So we are saying that corresponding to these angles A and C, we will have different values over here. So this is how we are going to select that what is the base and what is the perpendicular for a given triangle. Now next we are saying in a triangle ABC, angle B is 90 degree and it is given that AB is 5 centimeter. Next it is given that BC plus AC is 25 centimeters. So if this is 25, suppose we are saying that this length BC is X, then this length AC will be 25 minus X. By Pythagoras theorem, we will have 25 minus X square, that is equal to X square plus 5 square. So what we get is 625 plus x square minus 50x is equal to x square plus 25. These x square gets cancelled, and what we are left with is that 50x is equal to 600. So the value of x we will get, that is equal to 12. So it means the value of this BC is 12 centimeter, and this value it is 13 centimeters. Now we have to find sine A and cos A. When we are talking about this angle A over here, we are saying this is 90-degree angle. So this AC is the hypotenuse. For this A, we are saying this is the base and this is the perpendicular. So the value of sine A we will have, it is BC over AC, that is 12 by 13, and value of cos A, it is AB over AC, that is 5 by 13. Next we have to calculate the trigonometric ratios corresponding to cosecant C and secant C. So we are saying now this angle is a C over here. This side, this is the hypotenuse. The angle between this, we are talking about the T ratios corresponding to C. So this is hypotenuse and this will be the base now, and this is the perpendicular. So the value of cosecant C, we know that the cosecant is the opposite of sine. So its formula is hypotenuse over perpendicular. So it is AC over the perpendicular. Now we have it is AB in this case. So the answer we will get, it is 13 over 5. Similarly, secant C will be hypotenuse over base, that is AC over BC. The base in this case, it is BC. So the answer we will get, it is 13 over 12. So these are the required values. Next is in a triangle ABC. This triangle is given to us ABC. AB is equal to 7 centimeters. This is AB 7 centimeter. AC minus BC is 1. So if this value BC is x, we are saying if BC is x, then AC will be 1 plus x. This is a right angle triangle. So what we have is that x plus 1 square is equal to x square plus 7 square. This is by Pythagoras theorem. So we get x square plus 1 plus 2x, that is equal to x square plus 49. So we get 2x is equal to 48 and x is equal to 24. It means the value of this side, it is 24 centimeter, and the value of this side, this is 25 centimeter. Now when we have to calculate sine A and cos A, we are talking about this angle A, we are saying. So this is the base and this is the perpendicular. So the value of sine A we will have, that is equal to the value of perpendicular over here, it is 24 over 25, that is the hypotenuse. Then we are talking about cos A, that will be base over hypotenuse. Next, when we are talking about the sine C and cos C, we are talking about this angle is C now, the trigonometric ratio corresponding to this C. So for this C, we are saying this is the hypotenuse, this side it is the base, and this side this is the perpendicular. So the value of sine C we have, it is AB over AC, that is equal to perpendicular over hypotenuse, and that is equal to 7 over 25. Similarly, the value of cos C will be base over hypotenuse. The base over here, it is BC, we are saying this is the base. Hypotenuse, we are saying this is AC. So the answer we are getting, it is 24 by 25. Now next we have is in a triangle ABC, angle C is 90 degree. We are talking about this triangle over here, and we are saying this angle at C is 90 degree. In this side we are talking about this is the hypotenuse. Tan A, this is the angle A we are talking about. It is 1 by root 3. So tan A means we are talking about the perpendicular corresponding to this. It is BC over AC, and it is given to be 1 by root 3. So what we get is that BC is equal to x, then AC is equal to root 3 x. These values are mentioned over here. This is a right angled triangle. So the value of AB we have, it is square root of root 3 x square plus x square. That is equal to square root of 4x square, that is equal to 2x. This is the side AB we have. Now we have to find the value of sine A cos B plus cos A sine B. So when we are talking about the angle B, when we are talking about this angle B, we are saying corresponding to this A, this is the base and this is the perpendicular. Corresponding to this B, this is the base and this is the perpendicular. So when we substitute these values over here, we are saying it is sine A. The value of sine A we will have. Then we want the value of cos B, then cos A and sine B. First of all, we are calculating these values. So the value of sine A, we are talking about this angle is A. So it is perpendicular over hypotenuse, and cos A, it is base over hypotenuse. Similarly for cos B, we are saying this angle B we are looking over here. So the value of sine B, it is perpendicular. Now the perpendicular in this case, we are saying for this angle B, perpendicular is BC. So it is root 3x by 2x, and this value we get, it is x by 2x. So the answer in this case, it is 1 by 2 and this is root 3 by 2. So if we put these values in this formula, the first term we will get, it is 1 by 2 into 1 by 2 plus root 3 by 2 into root 3 by 2. So answer we get, it is 1 by 4 plus 3 by 4, that is 4 by 4 is equal to 1. In the second case, we have cos A. The value of cos A is root 3 by 2 into cos B. It is 1 by 2 minus sine A is 1 by 2 into sine B is root 3 by 2. The answer we get, it is root 3 by 4 minus root 3 by 4, and the answer comes out to be 0. We are saying the final answer in this case, it comes out to be 0. So the value of this term we get, it is 0. Now the next we have is, if A and B are two acute angles such that cos A is equal to cos B, then we have to prove that angle A is equal to angle B. So suppose we are talking about two triangles. One is this triangle ACD and second we are talking about BEF. We are talking about the trigonometric ratios corresponding to this angle A and trigonometric ratios of this angle B. It is given that cos A is equal to cos B. It means if we write from this triangle, the value of cos A we will have, that will be equal to AC over AD. From this second triangle, we are saying the value of cos B, that is equal to EB over BF. It is given that both these values, these are equal to each other. So what we get is that AC over AD, that is equal to EB over BF. So this gives us AC over BE. What we are doing, we are cross multiplying these terms. That is equal to AD over BF. We are talking about AC over BE. That is equal to BA over FB. these two sides ratio and ratio of these two sides, they are equal. So what we get from this is, if we equate these values equal to k, we get that AC is equal to k times BE and AD is equal to k times BF. Now we have to calculate the value of CD over EF. Now what is this value of CD? It is square root of, we are saying, AD square minus AC square over, what is this value of EF? It is FB square minus BE square. Now we are saying, if we substitute these values in this equation, so what we get is that in place of AD we are writing it is, this term we are talking about, in place of AD we are writing it is k times BF square minus, it is AC square means k square BE square, it is whole square root over, it is square root of BF square minus BE square. Look at this numerator part over here. From this term we can take k common, and what k common means, we have taken k square common, it comes out of square root, and what we are left with is BF square minus BE square. This numerator and denominator gets cancelled, and what we get is that this CD over EF equal to k. It means this ratio, this is also equal to CD over EF. This is the CD over EF. So what we get is that these two triangles we are talking about, one is the triangle ACD and second is the triangle BEF. Both these triangles, these are similar to each other, and if these two triangles, these are similar to each other, means they are equiangular. That is, angle A will be equal to angle B. That is the angle A we are saying equal to angle B, and this is what we have to